Hi friends, in this video we will discuss one more problem based on the topic Laplace transform of periodic functions. So the question is, find the Laplace transform of the periodic function f of t equal to t in the interval 0 to a and 2a minus t in the interval a to 2a. So this piecewise function is given. So this is a periodic function with period 2a. So 2a is a period here. So this condition says that only f of t plus 2a equal to f of t is nothing but a periodic function with period 2a. This function is also called triangular wave function. Triangular wave function. So let me see how to find Laplace transform of this triangular wave function. So for that we need a Laplace transform of periodic function formula. So we know that L of f of t formula, that is 1 by 1 minus e power minus ps integral 0 to t e power minus st f of t t. So this is the formula. Now in our case the value of p equal to 2a. The period is 2a for the triangular wave function. So take the p value is 2a now. So 1 by 1 minus e power minus 2a s. Instead of t, you have to substitute 2a. Then integral 0 to 2a e power minus st f of t dt. Now see, the given function is a piecewise function that has two parts. One part is from 0 to a. In this 0 to a, the function value is t, and another part is a to 2a. So in this interval the function value is 2a minus t. So just substitute these values here. So just divide this integral as two integrals minus 2as. Just separate this 0 to a e power minus st. In 0 to a, what is our function? F of t is t into dt. Next interval is a to 2a. So like this, 0 to a and a to 2a, like this, you have to separate this integral. Then apply the corresponding function value. So a to 2a, the function value is 2a minus t. So this is 2a minus t into d. Now, so this is looking like integral u dv form. So we have to apply a Bernoulli's formula or integration by parts formula. Anything we can apply here. So one small idea. So whenever you have one of the term is algebraic term, it's better to use Bernoulli's formula. So what is Bernoulli's formula tells? Integral over u dv. Integral u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc. Like that it goes. So here u dash, u double dash, u triple dash are etc. are successive differentiations. successive differentiations of u, and v1, v2, etc. are successive integrations of dv. We are having only two terms. One term is u, another term is dv. So that u you have to differentiate successively, and that dv you have to integrate successively. Okay, so the values are taken as u dash, u double dash, u double dash, and v1, v2, etc. So this combination given only here, uv minus u dash v1 plus u double dash v2, like that you should take. So this is the answer for this integral u dv. So you have to consider the given integral also in this format. So here we have to use one idea to choose which function is u and which function is dv. Okay, here two functions involved. One is exponential function, other one is algebraic function. Okay, the variable is t. Variable t means that t is not involving any function, exponential, sine, cos, log, inverse, like that. T is alone. T square, t cube, 2a minus t, like that. We are having function, they are called algebraic terms. Remaining, what function you are having? You are having e, okay, e power s minus st. Okay, here t is a function of exponential function. Therefore, this is exponential. Suppose sine st means there is trigonometric function. Like that, we can identify that function. Right. Now, use the condition called ILATE. I-L-A-T-E. Using this condition, easily we can find what is u. What is u we have to take it. Okay. So if we go like this, which terms comes first, that function is taken as u. So this condition is simply a choice of u. This condition is nothing but choice of u. Which one is u? We can choose using this condition. Now here the terms occurs exponential term and algebraic term. If we go in this order, algebraic term comes first. Therefore, algebraic terms is chosen as u. So here algebraic term is t in the first integral, 2a minus t in the second integral. So just you follow this formula, you can get the answer. Actually, no need to follow this formula also. I will tell one shortcut idea. We can follow that. The shortcut idea also based on this formula only. So easily you can understand that one. See how I will proceed. L of f of t equal to 1 by 1 minus e power minus 2as into. Now this is integral u dv format. Here now all of you know which is u and which is dv. So in first integral u is t and dv is e power minus st into dt. Okay, only two terms. You have to convert that whole integrand as only two terms. One is u, another is dv. Okay, u is t means remaining all the things, okay, are taken as dv. That's it. Okay, now apply in the formula. The formula tells what is first term is uv. First term is u, that is t. Okay, u is t, and v is nothing but integrating this dv. If we integrate this dv, we can get v. So if you integrate this dv, this side also you have to integrate. So integration of e power minus st is e power minus st divided by minus s. That is our v. Therefore, e power minus st divided by minus s. That's all. If you know the first term, easily we can complete this Bernoulli's formula. So Bernoulli's formula is very apt for algebraic terms. Okay. Right. Now next term is minus. Then differentiate this first function. Then integrate second function. This is the logic we have to follow until we get 0. Now what is the differentiation of t? Differentiation of t with respect to t is 1. The integration of e power minus st is e power minus st divided by minus s. Already one minus s is there, so minus into minus plus s square. That's all. Next term plus. Alternate sign you have to take. First term plus, next minus, next plus. Then again here differentiate first function, integrate second function. Same logic we have to follow. Now what's the differentiation of 1? Differentiation of 1 is 0. So whenever you got 0 of this, no need to integrate the second function because 0 into anything 0 only. So you can stop up to this. So the limits are 0 to 0. Similarly for next integral, the next integral u value is 2a minus t and dv is e power minus st into dt. So here the same dv is e power minus st dt. That means v will be e power minus st by s. U only changed. U is 2a minus t. Just replace here t as 2a minus t in the next integral. So you can get plus. So I will take here u values 2a minus t into integration of e power minus st is e power minus st divided by minus s. Next term, this is the first term. The next term is minus and take the first function, differentiate the first function. What is that? 2a differentiation. 2a differentiation is 0. 2a is a constant differentiation 0. T with respect to e is 1. Therefore 0 minus 1 is minus 1. Then integrate this function e power minus st divided by minus s into minus s, that gives s square. Next term is plus. Now differentiate this 1 minus 1. Differentiation of minus 1 is also 0. Differentiation of constant is 0. Right. Now the limits are a to 2a. Therefore this implies 1 by 1 minus e power minus 2as. First apply the limits to t here. Upper limit is a here in the first term. The upper limit is a. Apply the wherever t, apply a, so you can get a e power minus sa divided by minus s, then minus e power minus sa divided by s square. So this is upper limit minus lower limit is 0. We substitute 0, first term 0, second term e power 0 by s square. So the first integral limits are over. Then second integral limits you have to apply. Now apply 2a to the first function. So 2a minus t. Here t is 2a means 2a minus 2a is 0. 0 and everything is 0 only. Then minus into minus plus e power minus s a s into 2a. 2a divided by s square. That's all. This is the first term. Then minus lower limit. Lower limit is a. If you substitute a there, 2a minus a is a. E power minus sa divided by minus s. Then minus plus e power minus sa divided by s square. So the next step is 1 by 1 minus e power minus 2as. Now we can simplify this as a e power minus as divided by s. Take that minus in front. Then minus e power minus as divided by s square. Then minus into minus plus. The next term multiply this minus. E power 0 is 1. So 1 by s square. Next here plus e power minus 2as divided by s square. Then if you take this minus inside. So minus into minus you can get plus. So plus a e power minus as divided by s. Then plus into minus e power minus as divided by s square. That's it. Now see, minus a e power minus as and here plus a e power minus as by s get cancelled. So the remaining term is 1 by 1 minus e power minus 2as into 1 by s square is there minus and we can take that s square is common. In all the terms we are having s square, 1 by s square is common. Take that outside. So the remaining term is minus e power minus as plus 1 plus e power minus 2as minus e power minus as. So these are the remaining terms. So the next line 1 by 1 minus e power minus 2as 1 by s square into, now I will arrange this as 1, then I'm taking this 1 first, then minus e power minus as minus e power minus as. So minus 2 times e power minus as, next plus e power minus 2as. E power minus 2as can be written as e power minus as whole square. Okay, therefore here we can write this as 1 by 1 minus e power minus, here also we can write this as e power minus as whole square into 1 by s square. So these three terms is nothing but we are having this form a minus b whole square form. So a minus b whole square is a square minus 2ab plus b square. You just think of this formula. The place of a is 1 and the place of b is e power minus as. We substitute this ab value in the above formula, we can get this form. Therefore that is in the form of a minus b whole square. So a value is 1 and b value is e power minus as. So 1 minus e power minus as whole square. So here the denominator is 1 by 1 minus e power minus as whole square. So this 1 can be written as 1 square simply. So that is 1 square is again 1 only. Therefore this is a square minus b square form. So a square minus b square is nothing but a plus b into a minus b. Therefore this is 1 by 1 plus e power minus as into 1 minus e power minus as of 1 by s square. Here 1 minus e power minus as whole square. Now cancel this 1 power of 1 minus e power minus as. The remaining term is 1 by s square 1 minus e power minus as divided by 1 plus e power minus as. So already we discussed this formula in last problem. That is the formula for tan hx. So tan hx formula is 1 minus e power minus 2x by 1 plus e power minus 2x. Now here we need the power of the exponential is simply x. So simply x means we need to divide x by 2. So x by 2, tan h x by 2 is nothing but 1 minus e power minus x by 1 plus e power minus x. That's it. Very simple idea. Therefore we have the form this one. The place of x is here. Here x is nothing but as. Just replace x as as. So we can get here 1 by s square. 1 minus e power minus as by 1 plus e power minus as is nothing but tan h as by 2. So this is the Laplace transform of the triangular wave function. So in next video we will see some other problems. Thank you.